In this video tutorial, I will explore more about the perforated pattern type, especially for the uniform pattern type. The uniform pattern type is the perforated pattern type that has an equal spacing from one center of the hole to another hole. The distance calculation for the spacing will depend on the largest diameter of the selected tools, and the minimum gap or clearance between the tool. For example, if the largest tool is 10 mm diameter, and the minimum gap is 2.5 mm, then the distance from center to center will be 2 times of the largest tool radius plus the minimum gap, which will be 12.5 mm. The pattern types in this category are rectangle pattern, angle pattern, circular pattern, and spiral pattern. Let's now run image to punch by clicking the icon. Then, let's open an image file called circular gradient. Click the tooling tab, and then define the initial parameters before generating the pattern. For this tutorial, we will use laser mode tooling. Then, click the select tool to open the dialog box. Let's use round tool and set the minimum diameter to be 2 mm and the maximum is 5 mm. We set the total tool to be 5. Then click OK. We also set the minimum distance between the hole to be 10 mm. Next, let's set up the sheet size for this tutorial. Click the button in the Material Property group and define the width to be 2200 mm and the height will be 1600 mm. For other parameters, we just let it as it is. Then, click the first button on the Perforated Pattern group. As soon as it is clicked, the Perforated Pattern dialog box will be opened. From here, we can see that there are 8 tab menus representing 8 types of perforated patterns. The first 4 tabs are categorized in uniform pattern type. Let's first explore the rectangle pattern. The first parameter from the top left corner is ratio. By default, the ratio will be 1. This means that the vertical and horizontal distance from the center of one hole to another will be similar, as you can see from the result after generation. Let's click OK and click Generate button to generate the pattern. As you can see, the distance in x-axis and y-axis is equal. Hence the pattern will be a square pattern. Now, let's click the Pattern button again, to open the dialog box, and change the ratio to be 0.5. For all ratio less than 1.0, the pattern will look like a vertical rectangular pattern, as the distance in vertical direction will be smaller according to the ratio. For example, if the center to center distance of the pattern is 40 mm, and the ratio is 0.5, then the vertical distance will be 0.5 multiplied by 40 mm, which will be 20 mm. However, the horizontal distance will remain the same as 40 mm. Now, let's click OK to exit the dialog box. Then click the Generate button to generate the pattern. As you can see, with 0.5 ratio, the pattern will look like a vertical rectangular pattern. Let's open the Pattern dialog box again and change the ratio to be 2. Then click OK and generate the pattern again. From here we can see that the pattern is in horizontal rectangular pattern, as the distance in vertical direction is multiplied by the ratio of 2. However, the distance in the horizontal direction is still remain the same. For most of the case, ratio value of 1 will be the common setting and we will set it as 1. Now, let's talk about the inclination pattern angle. This parameter is available for both rectangular and angle pattern. We can define the value from -60 degree to 60 degree, which by default, it will be 0 degree. This parameter is used to rotate the whole pattern either in counterclockwise or in clockwise direction. Let's now set the inclination angle value to be 30 degree and click the Generate button. Then, let's set the value to be -30 degree and click the Generate button again to see the result. From here, we can see the different angle on the pattern when the inclination is set up in different value. Before we are going to talk about the tool rotation. We use triangle tool shape and specify the minimum bounding circle to be 5 mm and the maximum to be 10 mm. The tool rotation parameters are available for both rectangular and angle pattern as well. There are 3 options. First is the rotation according to the inclination angle. This first option, all the tool will be rotate in the same direction with the inclination angle. If the inclination angle is 0, all the tool rotation will only based on its default rotation. The default rotation is defined when you create the tool in the tool dialog box for punching mode, or when you define the selected tool for laser mode. For the second option, the tool rotation will be based on its default or base rotation. So if the inclination set to 60 degree, but the tool rotation is the second option, then the result will be different. For the third option, all the tool will have a random angle which will never be the same every time we click the Generate button to generate the pattern. Let's click the third option, then click the Generate button. Then click for several times and we can see that the angle rotation is different, as this is for the random angle rotation. For the clearance gap parameter, there are 2 options. The first is to calculate the center to center based on the bounding circle that cover the whole tool shape. From this illustration, the largest tool shape is a rectangular tool, so the red circle is the bounding circle of this largest tool that will be used to calculate the center to center distance, which in this case, it will be the diameter of bounding circle plus the minimum gap clearance. Hence the distance for x direction and y direction will be equal. However, when the option 2 is selected, the actual width and height of the largest tool are the parameter that will be used to calculate the center to center for both x-axis and y-axis. We use a rectangular shape for the tool type. Select the rectangle tool shape and use all the existing parameter. We change the minimum gap to be 2.5 mm. Click OK when finish. Then, we open the perforated pattern type and select the diameter maximum for calculation. For other parameter, we will revert them all to its default values. Then, click OK to close the dialog box, and click Generate button to create the pattern. And we can see that the distance from center to center in both direction is similar. This is because we use the bounding circle for calculation. Next, we open again the pattern type dialog box and select the second option for gap calculation. Then click OK and generate again. From here we can see a different pattern result. With the selection of clearance/gap calculation parameter, the distance from center to center will be calculated differently for x and y directions, which give a different distance for each direction. Click the pattern type again to open the dialog box and we explore the newest features for rectangular pattern type. The tool offset parameter will enable users to offset either the row or the column up to 50% of its width, or its height. The offset pattern will look like the formation of brick, which give a nice pattern design. In order to determine which axis to be offsetted, user can check the button to use the offset in vertical direction. However, if this parameter is unchecked, it will offset in horizontal direction. The sliding control button below will be used to define the offset percentage. If in horizontal direction, the negative value will offset to the left, and if positive value, it will offset to the right. If the vertical direction is checked, the negative value will offset the column downward and it will be upward for positive value. In case we want to revert all offset value as default, we need to click the 0 button. Now let's have a demonstration to use the offset parameters. Now let's explore the angle pattern. Please click the second tab to go to Angle Pattern menu. From here, we can see that the tool rotation parameter has similar function to the one we have explored in rectangular perforated pattern type. We can also see that there are inclination pattern angle that we have explored previously. However, there is a new and unique parameter that only available in their angle pattern type. This is the perforated pattern angle. This parameter will calculate the pattern between 15 degree to 75 degree, and the most common angle are 15, 30, 60, and 75. Let's specify the angle to be 15 degree and see the pattern result. Then we can also select the pattern angle in 30, 60, and 75 degree to see the result. Then we change the inclination angle as well as its tool rotation parameter and see the result. Again, the combination of these parameters will create unique pattern and give lots of opportunities to design a good perforated pattern for your project. Now let's talk about the circular pattern. The first parameter is circular coverage area. This parameter is about the pattern coverage. If the option 1 selected, the perforated pattern area will only cover the area of the circle inside the perforated pattern effective area. However, if the rectangular coverage is selected, all the effective perforated pattern area will be filled with the perforated pattern. Let's open the perforated pattern type dialog box again for circular pattern. The next parameter we want to explore is the angle direction. There are 3 options for this parameters. The first one is local rotation. If this is selected, the rotation of all tool will be based on its tool default angle rotation, which is commonly to be 0 degree. The second option is global rotation. When this is selected, the tool rotation will be calculated based on its current position and the center point of the circle pattern. Therefore, the rotation for each tool will be on parallel with the circular shape. The third option is a random option. This parameter is similar to the previous pattern and will have random rotation angle that different every time the Generate button is clicked. We can also change the center position of the circular pattern by manually defining the X and Y direction. By default, the centroid of the circular pattern is always be in the center of the effective sheet size, which is 0, 0. Let's talk the last parameter in the circular pattern. This parameter is to define the circular seeding that will construct the circular pattern. We can select the seed from 3 to 9. Now let's try to see the result when we select the circular seed parameter. Now we are going to explore the last pattern type in the uniform pattern group, which is the spiral pattern. This pattern has similarity with the circular pattern, such as pattern coverage and centroid parameter, where we can define the position of the centroid of the pattern. For the angle direction, the function is slightly different with the circular pattern, as they have 4 options instead of 3 options. The tangential angle is only belongs to spiral pattern, where the angle calculation is based on the current position of the tool compared to the position of the previous tool. Let's see the different option one by one. Start from option 1. Option 2. Option 3. Option 4. The last option in the spiral pattern is the incremental angle factor. This parameter is to define the density of the spiral pattern. If the value is less, the tool to be used to generate the pattern will also be less, However, if the incremental angle factor has more value, the spiral pattern will have much more dense. In order to understand the incremental angle factor, we can only learn that by doing some experiments to get the pattern that we want. This is the end of the video. I am hoping this will provide you a good information.